block and tackle system. For this system, you have to first understand that in this type of pulleys, two blocks of fixed pulleys are used. Okay, so you have two blocks, one is upper block, one is upper block, and one is lower block. So there are two blocks. Okay, now this upper block have several fixed pulley attached to the rigid support. Okay, that will be fixed. Okay, so fixed pulleys and that are attached, so that cannot move. That is for the upper block. And for the lower block, it will be several fixed pulleys. Okay, so fixed pulleys, but they are movable, so it can move. The lower block, the pulleys can move. This is actually known as block and tackle system or arrangement, where you have two blocks, upper and lower blocks. Now your number of pulley which you are using in the lower block, okay, so the number of pulleys which you are using for the lower block, that can be either equal to or less than your number of pulleys in the fixed upper block. So you have number of pulleys in the upper block. Now your lower block should have either equal to or less than. Okay, it cannot be greater than. The number of pulleys cannot be greater in the lower block. This you have to remember. Now this is your block and tackle for 5 pulleys. Okay, 1 2 3 4 and 5. So these are for 5 pulleys, and this is for 4 pulley. Now in the upper block, here you have 2, lower block you have 2, so both equal number. So this can be one case, and other case can be 3 blocks, 3 pulleys in the upper block and 2 pulleys in the lower block. Now you see here I have not drawn the string. Now how to draw that? Here we can understand that definitely there will be a string, okay, that will pass around all these pulleys. So if it is for your block and tackle for 5 pulleys, then your string, one end of the string will be attached to the hook of the lower block. So you will start from here. See, you will start like this. Okay, like this, then moving on like this, and then ending here. Okay, now giving the arrows. So starting from here, it will go like this. Okay, so you will start from lower block. Okay, and these are your tension. So tension will act in the upward direction, and effort, you will give your effort from here. This is for your block and tackle for 5 pulleys. Now for 4 pulleys, you will start from upper, okay, upper block, from here, from this hook, your string. So like this, moving on, and then end over here. Okay, so here you go. Give your arrow from here. Okay, so this is your tensions. Follow the string. So here you have one string, here you have, so here will be one T, then here you have other string, so T and T, so you have 4 tensions. Okay, one for this you're giving here. Okay, this is my effort from here, and our load is attached over here. Load is attached to the movable block, that is load is attached to this movable lower block, and you will apply the effort from this free end. Okay, here you will have one T that is going to act in the upward direction, and here also this T will be in the upward direction, and effort will be in the downward direction. Okay, so there will be one more T over here. Now let's calculate the mechanical advantage for first this one. Okay, for 5 pulleys. So mechanical advantage. Now for this one, you see how many for load is actually, you see your load is over here. So how many strings are involved for this? 1, 2, 3, 4 and 5 strings. Okay, so the tension in this 5 segments of the string is actually supporting your load. Okay, so you will write over here that load is equals to 5T and effort is equals to, effort you have from here, so here you have only one T which is over here, so you will write T. Now it is equals to load by effort, so let's calculate over here. 5T by T, which is equals to 5. Okay, this is for your 5 pulleys. This is for your 5 pulleys. Now for your 4. For 4 you have, see, this is your load and how many strings are there? 1, 2, 3, 4. So 4T and effort equals to T. So mechanical advantage equals to load by effort, 4T by T, which is equals to 4. So you see that over here your mechanical advantage is 5 and over here your mechanical advantage is 4. When was your mechanical advantage 5? When you used 5 pulleys, and when is 4? When you use 4 pulleys. So by this we can understand that the total number of pulleys, okay, that is actually your mechanical advantage. See, if you say that L equals to NT, N, suppose N is your total number of pulley. Now you see over here L equals to 5T. So your 5 was what? Total number of pulleys for your this one. So here you can write N. Okay, N is actually your total number of pulleys. Okay, total number of pulleys. For first case my total number of pulleys was 5 and for the next it was 4. So here for the so I can write load equals to NT and effort will be T, because you see here it was only T for both the cases. So you can say mechanical advantage equals to load by effort nt by t, which is equals to n, and which is actually equals to total number of pulleys you are using. So it will be very easy for you to calculate the mechanical advantage. You just have to see that how many pulleys you are using. You are using 5 pulleys in this case, so your mechanical advantage was equals to n, so it is 5 for that case. And for the second one, you are using 4 pulleys and your mechanical advantage was coming to be 4, so that is your equal number of pulleys used. So you can understand, so it's very easy for you to calculate mechanical advantage like this. Now if I say that effort, what is actually effort? Load by mechanical advantage. From this I can write load by mechanical advantage. And how much we got? Mechanical advantage we got n, so this is n. Okay, now you see your effort is actually getting multiplied n times. See, if you calculate load, it is E n, or write it like this, ne. So you see your effort is getting multiplied. See very carefully that your effort is getting multiplied n times. Okay, and this is actually acting as a force multiplier. So as your effort is getting multiplied n times, where n is actually your total number of pulleys used, so you can say that it is acting as a force multiplier. Okay, now let's calculate velocity ratio. Velocity ratio for we will calculate distance moved by the effort by distance moved by the load. Now if we say that load is moving up through a distance of d, okay, so load is moving up through a distance of d. Now how we can get effort? Effort will be actually nd. Why it is going to be nd? Okay, sorry, this is my distance traveled by load and distance traveled by my effort. So distance traveled by my load is equals to d and distance traveled by my effort equals to nd. Now why nd? See, my effort is ending over here. Okay, so if it is ending over here, it is actually covering a distance of nd. Okay, why nd? Because you see each section of the strings are supporting the load. It is actually supporting the load and each section of the strings are supporting, and all are having the length of d. So we can say nd. Okay, so velocity ratio equals to nd by d, which is equals to n. So velocity ratio is actually equal to the number of strands of the tackle, number of strands which is actually supporting the load. So now efficiency, mechanical advantage by velocity ratio, n by n is 1 or 100% efficient. Now tell me, can my efficiency be 100%? It can be only 100% if I say that it is an idle situation, when there is friction or there is weight. Okay, so if these things we are actually neglecting, then we can say that efficiency is 100%, isn't it? And if I say that I have friction in the parts of the pulleys and weight in the lower block if I'm having, then the mechanical advantage should decrease, and hence that efficiency should also decrease. We can't say that it is equals to 100%. That can only be possible if it is an ideal situation. Okay, actually it is not possible. So what is actually possible here? It will be mechanical advantage can decrease and your efficiency will also decrease if your mechanical advantage is decreasing.